We spend our lives wary of what hides in the dark, yet we are constantly mesmerized by the mysteries we can't quite see. That sudden spike in your heart rate when you hear a strange noise at night is a highly tuned survival mechanism inherited directly from our earliest ancestors. On the prehistoric savanna, a rustle in the tall grass might just be the wind, or it might be a hungry predator. The early humans who paused, assumed the worst, and retreated were the ones who lived long enough to pass on their genes. Evolution favored intense caution over curiosity when the stakes were life or death. The anxiety you feel when stepping into unfamiliar territory today is the echo of a successful, life-saving biological strategy. To understand why this ancient strategy still influences us, we have to look past the environment and examine the physical structure of the modern brain. This map shows the amygdala, a small almond-shaped cluster of nuclei deep within the brain that processes emotions and fear. It acts as an involuntary scanner, immediately lighting up the moment it detects a stimulus it cannot easily categorize. The amygdala cannot differentiate between the physical threat of a wild animal and the abstract uncertainty of a vague late-night email. The chemical response is identical. The result is a biological system mismatched with the relative safety of the modern world, leading to frequent false alarms. Instead of rival tribes or apex predators, our brains now scan for threats in ambiguous social interactions, unpredictable economic news, or texts that simply say, "We need to talk." Neuroscience demonstrates that these unclear situations trigger higher levels of panic than actual identified dangers. Not knowing what is going to happen generates a more intense reaction in the brain than knowing for certain that a negative event is coming. This chart compares human stress levels when waiting for an unknown outcome versus experiencing a guaranteed negative one. People report lower stress when they know they are definitely going to receive a mild electric shock than when they are told they might receive one. We will often choose guaranteed physical discomfort just to escape suspense. The brain craves predictability. The moment an outcome is decided, even a bad one, the brain can stop running exhausting simulations, causing systemic stress levels to immediately drop. Human anxiety is often the product of a brain rejecting a lack of data, rather than a response to an actual threat of harm. Early human societies realized they had to manage a brain that was constantly wary of the dark corners of the world. Their solution was to give shapes and names to the things they couldn't see. Cultures invented folklore, mythological monsters, and divine spirits to take the infinite void of the unknown and package it into specific, recognizable characters. These stories acted as a collective psychological shield. Instead of dealing with vague, overwhelming dread, communities could share a localized fear with a beginning, middle, and end, providing a structured way to process anxiety together. This ancient coping mechanism survives in our entertainment. We pay money to sit in dark movie theaters or walk through haunted houses, seeking out adrenaline spikes in an environment we know is secure. Over millennia, human culture took a paralyzing biological instinct and molded it into a shared tool. What began as a survival mechanism evolved into a method for communal bonding and controlled thrill-seeking. But we are not strictly bound by these instincts because our brains possess neuroplasticity, the ability to physically reorganize neural connections in response to new experiences. This is the foundation of exposure therapy, a psychological treatment where people confront their fears in a controlled way. Through gradual, systematic contact with uncertainty, the amygdala's sensitivity actually decreases over time. When you deliberately reframe an ambiguous situation as an opportunity, you build new neural pathways. These pathways allow the prefrontal cortex, the part of the brain responsible for complex thinking, to exert more control over the default panic response. While we are born with a fearful biological default, we have the capacity to strengthen the specific neural circuits that regulate and dampen that ancestral response. This connection creates a structural crossover. The neural pathways that mediate anxiety are physically linked to our reward centers. Exploration triggers the release of dopamine, a chemical governing pleasure and motivation. When we navigate new environments, our brain rewards discovery with a sense of accomplishment. Fear kept ancestors alive, but curiosity drove them to migrate and develop tools to survive. Stepping toward the unknown contradicts millions of years of survival logic. It is this specific ability to override our own biology that allows us to inhabit environments and solve problems our ancestors could never have imagined.